Continuing on with the 9.4, we're going to look at now dividing radicals. So just like I was talking about with the multiplying, you can divide anything as long as they have the same root. So if they both are square roots, you can divide them. If they both have cube roots, you can divide them. Fourth roots, you can divide them, so on and so forth. If they have no root, you can divide them. So the biggest rule for division is that a radical is not allowed to be in the denominator. We're going to look at some examples where we are left with a square root in that denominator. That's the bottom part of the fraction, and we're going to have to do a step in order to get rid of it. So a radical can be in the numerator. It cannot be in the denominator. So let's look at number 1. We're going to simplify this. So these are both underneath a square root, so we can divide them. So the square root of 40 divided by the square root of 10. 40 divided by 10 is 4. Notice we leave it underneath the square root. And then we know that the square root of 4 is 2. So 2 is just our answer. Number 2, they're both under a square root, so we can divide them. We'll leave our answer underneath the square root. So 55 divided by 5 is 11. Now we need to think, do we know the square root of 11? No. Can we simplify the square root of 11? Well, it's a prime number. It can only be divided by 1 in itself, and that's not going to help us simplify this. So the square root of 11 is our final answer. Number 3, they're both underneath the square root, so we can actually divide them. So we'll leave the answer under a square root. So 96 divided by 8 is 12, so we have the square root of 12. Do we know the square root of 12? No, but we can simplify it because we can split that into the square root of 4 times the square root of 3. Now we know that the square root of 4 is 2. Carry over your square root of 3, and you have your final answer. On number 4, we have 2 square roots, so yes, we can divide them, but if we put 2 divided by 3 in a calculator, we're going to get a decimal. And you don't want to have any decimals in our answers or underneath the square root. So this is one of those times where we're going back up here where it says that the biggest rule is that you're not allowed to have a radical in the denominator. And since there's nothing that we can do with this right now as far as division, we see that we have a square root of 3 down here, and we're not allowed to have that. So when we see that, what we're going to do is we're going to multiply both the top and the bottom of that fraction by the square root of 3. So whatever this radical is down here, you're going to multiply that to both parts of the fraction. So thinking back to your rules of multiplication, you got the square root of 3 times the square root of 2, which is the square root of 6. You have the square root of 3 times the square root of 3, which is the square root of 9. The square root of 6 we do not know, and we cannot simplify it because even though we can split it into 2 and 3, we don't know the square root of 2 or 3. So we're going to leave that square root of 6. We do know the square root of 9 is 3, and so now you can see that we have gotten rid of that radical that was in the denominator. So the square root of 6 over 3 will just be our final answer. On number 5, you see that the 8 does not have a square root around it, so we cannot divide these. But again, we see that we have a square root in the denominator, and that is not allowed to stay down there. So we're going to have to multiply the top and the bottom of the fraction by that square root of 11. Thinking back to your multiplication rules, we cannot multiply 8 and 11 because 8 does not have a square root around it. So we're going to carry over the 8 and carry over the square root of 11. And then we have the square root of 11 times the square root of 11, which is the square root of 121. Carrying over that 8 square root of 11 again, square root of 121 is 11. So before we say that this is our final answer, we want to take a look at the two numbers outside of the radical, 8 over 11. Is there a number that can divide both 8 and 11 besides 1? And there is not. So we cannot simplify 8 over 11. So that's just going to be our final answer. If you were given something like a final answer of, let's say, 3 square root of 7 over, let's say, 9. So let's say you were given this. 3/9 can be simplified because both of these are divisible by 3. So if I divided both of those by 3, 3 divided by 3 is 1, so we'd have 1 square root of 7, and 9 divided by 3 is 3, so our final answer would just be the square root of 7 over 3. So that's just another example similar to number 5 where the fraction could be simplified further. On number 5 itself, we could not. On number 6, square root of 27, or 1 over 27. Remember from earlier on, we can split this up into the square root of 1 over the square root of 27. We do know that the square root of 1 is 1, but we don't know the square root of a 7, or 27. There's a couple of ways that we could go about doing this. What I suggest you do is to simplify this first. So we can split 27 into 9 times 3. So we have 1 over the square root of 9 times the square root of 3. So then that gives us 1 over the square root of 9 is 3, square root of 3, which is okay except for the fact that we can't leave the square root of 3 down there. So following the rules from above, we're going to have to multiply top and bottom by the square root of 3. 1 times anything is itself, so we have the square root of 3 on top. We have this 3 that we're going to carry over, and then square root of 3 times square root of 3 is the square root of 9. Carrying over that square root of 3 one more time. We have that 3 again that we're going to carry over, and then the square root of 9 is 3. So finally, we have the square root of 3 over 3 times 3, which is 9. Now, I know we can simplify 3/9, but this isn't a 3. This is the square root of 3. The only way we could simplify is if these both had a square root underneath them. So that's as far as we can take that problem. On the last one, we're going to do the same thing. We're going to split this up into the square root of 3 over the square root of 50. We cannot simplify the square root of 3, so I'm going to leave that. But we can simplify the square root of 50. So we can split that into square root of 25 times 2. Carrying over the square root of 3 again. We know that the square root of 25 is 5. Carry over the square root of 2. So now we see that we have a square root in the denominator. That can't stay there. So in order to get rid of it, we multiply top and bottom by the square root of 2. So let's see, both of these are underneath the square root, so we can multiply them. So 3 times 2 is 6, so we have the square root of 6. We're going to carry over this 5 because there's nothing we can multiply it with. And then the square root of 2 times the square root of 2 is the square root of 4. Simplifying this even further, carry over the square root of 6, carry over the 5, and then the square root of 4 is 2. So now we have the square root of 6 over 5 times 2 is 10. Again, we cannot simplify these because this one has a square root and this one doesn't. So that's as far as your answer can go.